Good day. It's Tuesday, September the 14th. I'm Martin Gagel with Market Radius Research. And today I'm very happy to have CEO Andrew White and CFO Mark Korol of Char Technologies joining us today. Char Tech is a clean tech company specializing in high temperature pyrolysis, converting woody materials and organic waste into renewable gases and biocarbon. And remember, this is neither a recommendation or investment advice. We're here to learn about the company, do your own due diligence. So we're going to start off with a quick overview, and then we'll dig into the details of their recent news announcement. So Andrew and Mark, thanks for joining us today, and let's hear the story.
Fantastic. Thanks for having us, Martin. And as you mentioned, this is our second time going through this story with you, so we appreciate the opportunity. I'll work through the deck here fairly quickly as an introductory overview for those who are new to the story and a quick summary for those who are familiar. So I'll just add that the deck is available on our website for those of you who want to spend a little more time with it. And I'll point out, this is the August deck. We had a minor technical difficulty with the updated corporate presentation, but that is on our website. So at a high level, Char Technologies is a clean tech development and environmental services company. But the real excitement and really where our opportunity lies is with our proprietary technology called high temperature pyrolysis. So I'll talk a little bit more about what that is, but it essentially converts woody materials and organic waste, as Martin mentioned, into renewable natural gas or green hydrogen, as well as a suite of biocarbons. And so there's a lot of great positives about this story and about the technology. One is it is carbon negative. So through the use of the technology, we reduce net greenhouse gas emissions. The technology is modular, so it sits on a skid. Our largest kiln size can still ship in a shipping container. So when we deploy systems, we're not building plants on a site, we're building all the equipment in a factory and then assembling it on site, which really reduces a lot of the commissioning risk. And as a modular platform, we're still using that exact same kiln, whether we're producing renewable natural gas, whether we're producing green hydrogen, and whichever the biocarbons we're producing, it's the same oven, essentially. We do have...
Andrew?
Yes.
Sorry. So essentially you load it onto like a shipping container or the back of a truck, and you do the assembly in your London facility. And let's say for this California deal that you announced, you'd throw it on the truck and then ship it all down to California and then attach it and plug it in and so forth down there?
Yeah, we won't be building it in London, but the rest of it is exactly it. We have it built, we travel to the manufacturing site, we do factory acceptance testing, so it's all assembled, we turn it on, we make sure everything works, disassemble the modules, so the kiln is one, sort of the feed hopper is one, each piece is on a skid, put those in containers go to site, and we just take them out and plug them all back in. So it's kind of like a Lego building block almost.
And the construction is all outsourced. So you're not hiring construction guys or welders or whatever yourself. That's just a contract to a third-party contract manufacturer.
Correct, yes. So modular, we do have an existing steel client. So that's from our previous discussion, selling this clean fire, which is a biocoal, which I'll talk a little bit more about. We also now have an existing client with Hitachi, Zosen, and Inova in California, which I'll talk a little bit more about as well. We have patents and intellectual property, both from published patents as well as know-how. And we have two delivery models. And those will make a little bit more sense when we talk about our market verticals. But on the one hand, it's system sales and recurring revenue. So that's sort of that upfront capital equipment sale, and then ongoing revenue from technology licensing and services and maintenance contracts. The other model is the utility model, where we own the facility or partially own through joint ventures, where we can realize the ongoing revenue opportunity from things like renewable natural gas and green hydrogen. We're generating revenue. We have an active pipeline of over 100 million in projects. Recently in February, we completed a $6 million private placement. We continue to have a strong balance sheet and carry no debt. So this is, on the technology side, this is what high temperature pyrolysis looks like. So this is our London facility. This is where we're making biocarbon for that existing steel client, making biocoal out of this facility. The key here are two pieces on the technology side. One is that it's zero oxygen. So there's no combustion possible at our high temperatures. So we operate in about 800 degrees Celsius. We just get thermochemical conversion. So without oxygen, you can't burn stuff, but we're able to heat it up to these high temperatures to create our products. The other piece is that it's self-sustaining. So we produce things like green hydrogen and renewable natural gas. We take a small amount of what we produce, and that fires the kiln. So once it's operational, we have a small amount that we recover and burn in the system to create our heat. And then the rest is available for sale. So once it's operating, we don't need any external sort of gas or thermal inputs. It's self-sustaining from that perspective.
Andrew, on the pyrolysis is a well-established technology. I don't know, it's been around a long time. And you have some patents around that. Is it, could you describe sort of the nature? There's obviously know-how, like the temperature and, I don't know, flows of things in there. But on the patent side, how do you patent something that's been so established for so long?
Yeah, and there's kind of two buckets. One is on the process patent side. So we have published patents around processing things like anaerobic digestate, the outputs of a biogas plant, and the ability to convert them into some of these value-added products. So there's sort of the process. So in a way, it's like the recipe book patents. You know, what are we putting in and what ratios at what times and temperatures. And I think that gives a really strong patent fence, because if you go outside of those operating ranges, you can't really make the quality product. On the pyrolysis system itself, so the oven, we recently announced that we completed a technology licensing agreement. So we now have exclusivity on the oven piece, and where the IP for that sits is all about the ability to get the temperatures high. So if you look at other pyrolysis technologies, other competitors, other systems that have been around for a long time, they can only operate sort of 400 to 500 degrees Celsius. And the ability to sustain 800 degrees Celsius is a crucial competitive advantage. And that the design of the system allows that high temperature, which is very, very important for our other IP and ability to compete in the market.
Sir, and I don't want to get too technical here. I don't know, to me it's an oven without any oxygen. You just turn up the thermostat or put some more fire underneath it to get it at a higher temperature. What is there a simplistic kind of explanation to what makes it hard and why other people have a hard time doing that?
Yeah, I mean, it's in the way that the system is done. So sort of other pyrolysis companies and technologies, what they'll actually do is they'll produce this syngas. That's the gas that comes out of the system. They'll burn it in a separate burner, and then they'll take the heat from that burner and put it around the outside of the kiln. And that limits the amount of heat transfer, so the ability to get the system really hot. The other option that competitors could do is they could run natural gas through the kiln burners to get it that hot, but that defeats the carbon neutrality of the whole process. So the ability to recover the syngas in such a way that it can be burned in these burners to create the heat energy to get us these high temperatures, and a little bit on the layout and a few other kind of trade secret aspects that go along with it, allow for that high temperature operation.
All right, thank you.
Absolutely. And so that's kind of what the technology looks like. Now, from a market perspective, this graphic on the right kind of shows the three primary market verticals where this high temperature pyrolysis process that we've developed is being deployed. So starting from right to left, on the right-hand side, we have wood and agricultural products. So in that market vertical, that's where we are primarily pursuing the utility model. So that's where we're building, owning, operating our own facilities, either completely on our own or with joint venture partners, processing things like wood waste, residuals from sawmills and construction demolition, wood waste, and we're getting into things like railway ties and converting that material into clean energy and biocarbon. And specifically for that market, that's where we're producing renewable natural gas, where there's some tremendous demand for renewable natural gas in pipeline. And the biocarbon, that's where we're creating this biocoal that can be used to substitute coal in heavy industrial applications like steel, like metallurgy, basically a met coal replacement. Jumping to the left side, the biosolids. Biosolids are the leftovers from a wastewater treatment plant. So kind of like a fiber, but there's some challenges in it in that this second check mark, this PFAS forever chemical, and I'll talk a little bit more about that in a second, but basically forever chemicals make their disposal very, very challenging and very expensive. So we can process biosolids through this system because, again, of this high temperature, we're able to destroy those forever chemicals. And in the biosolids case, we make a biocarbon that can be used as a soil amendment, a fertilizer, a carbon sink, generate carbon credits. Most of the energy we produce from the biosolids goes to drying them, but it's really solving this disposal cost. And in that market vertical, that's where we're selling plants, getting that capital equipment sale, and getting some recurring revenue from ongoing service and support. So that leaves the middle market vertical, digestate and compost. Now, digestate is probably a term not a lot of people may be familiar with, but it's the leftovers from a biogas plant. So for those of you who follow ZBEC or Green Lane, those gas upgraders, those two companies sell into the market, service biogas plants. One of the outputs of a biogas plant is anaerobic digestate, but it is very similar to a compost. And so we can process that, again, produce biocarbons, and we can produce green energy either in the form of green hydrogen or renewable natural gas. So that's the market that our project with Hitachi, Zosen, and Inova in San Luis Obispo fits. We're managing their digestate that their plant produces through pyrolysis, producing biocarbon and a green hydrogen. And we're now, that deal has been signed, the definitive agreements in place, and we're now moving forward with deployment on that project. And in that market vertical, it's kind of a blend of build, own, operate, and capital equipment sale.
With the HZI deal or any of these anaerobic digesters, so they have they don't use everything up. They get sort of an end product as well. And then your pyrolysis process can take that digestate, extract even more good stuff out of it, leaving, I guess, even less physical or hard end product, and extra energy comes out. Is that basically it? You take the process one step further?
Yes, exactly. And I'm going to borrow Mark's favorite explanation here, and I hope, Mark, you don't mind, but I'll give you full credit for it. And that is the anaerobic digesters, the biogas plants. Conceptually, if you just use an orange as your model, the biogas plant basically squeezes the juice out of the orange. So they extract energy, the juice, but you're left with a rind that has, some of that fiber in it. It's still got a bit of juice in it, and that comes out of the plant. That's what we take in as our feedstock to further extract energy and convert that into a more value-added biocarbon.
And then from that, you get some RNG or some hydrogen, or do you only get biocarbon at the end of that?
Yeah, so for that market, we get both biocarbon as well as the gas. And kind of the gas steps are, as it comes off the kiln, we're about 40% by volume hydrogen. We can then put it through what's called a water gas shift process to up that hydrogen to about 60% by volume. Now, at that point, like with the Hitachi plant, we extract the green hydrogen to market. If we're in a jurisdiction where the green hydrogen market is still evolving, but the market for renewable natural gas is well established, we can take that green hydrogen through one more process step called methanation, and that converts the hydrogen plus some of the carbon in our process into methane, renewable natural gas.
Okay, and then so your end product is the RNG or the hydrogen, and the biocarbon within just gets burned again in a steel mill or something like that.
That's right. So either into a steel mill or a thermal process where it's offsetting coal, or as a soil amendment, because remember, this digestate and this compost, it has nutrient value in it, and we don't lose the nutrients. So we're able to have a fixed carbon that can generate carbon credits because we're fixing carbon into the soil kind of forever, and we're bringing those nutrients back to the soil. So there's a couple market applications for the biocarbon.
And do you have any leftover materials that are like that you have to throw in a garbage dump, or that are, I don't know, radioactive or anything bad with them, or just it's all reused and your whole concept of this carbon cycle is completed and the cycle starts again?
Yeah, that's exactly it. Is we're not creating any additional waste product, which I think is fantastic. And there's going to be continued need for carbon within some of these industrial applications. You know, even as steel mills, for example, move into lower carbon processes like electric arc furnace, direct reduction processes, they actually still need a little bit of carbon in those systems to facilitate the chemical reactions. And so there's still a need for solid carbon. And certainly we think getting solid carbon out of a cyclical carbon cycle is much better than digging it up from the ground where it's permanently sequestered in the form of coal.
You mentioned on the wood and agricultural, the woody waste is, you're planning more of the utility model, but on the biosolids, that's more of a sell the equipment. Is that because the biosolids is like a lower margin business, so you just like the inputs versus outputs, or why do those markets get segmented by sort of different business models?
Yeah, so on the wood into RNG, there is a huge demand, even just in Canada, for RNG. So a research report that was put out by 8 Capital kind of showed that Fortis BC, so the gas utility in British Columbia, they've got a mandate of like 15% of their grid to be renewable. And for them to hit that number, they need up to 45 pentajoules of renewable natural gas. Now, a pentajoule is 1 million gigajoules, and a gigajoule is a unit of energy. In Canada, in 2019, only 6 pentajoules were produced. So the reason we are very excited about the build, own, operate opportunity in that space is there's no one that has commercial biomass to RNG operating in Canada. So we've got a fantastic first mover advantage coupled with a huge demand. The same demand exists in Quebec through Anergy, and other gas utilities are following suit. So there's a huge market opportunity that we can tap into. Now, the reason we're not pursuing the build, own, operate in the biosolid space is that's a very, very well-established space with some very large players. We see our long-term viability in woody and agricultural products into renewable natural gas. But because of our ability to destroy these forever chemicals, there's a short-term opportunity to sell our equipment to the existing players in the biosolids markets, get those upfront CapEx sales, drive revenue into the company. It's the opportunities there, but we don't want or see the company becoming a biosolids merchant facility where we're accepting tip fees to process biosolids, just because of those two different market dynamics.
All right.
And sorry, let me turn off this this beeping here. I don't know if you can hear that on the mic, but so that's kind of the overall market and technology. So I know we talked about each of these outputs, but I've got a quick slide on them all, and hopefully that will help cement some of the concepts we're discussing. So on the biocoal piece, what's the demand? Why is there the interest? And it's really this quick facts on the top right. It's that 1 ton of coal, when burned or consumed, gives you 3 tons of greenhouse gas emissions. 1 ton of our biocoal that we call clean fire replaces 1 ton of coal. So it's a drop-in replacement. As far as the blast furnace is concerned, there's no difference. It's the same stuff. But 1 ton of coal gives you pretty close to 0 greenhouse gas emissions. And that's the key, is that with greenhouse gas pricing, at the moment anticipating being about 170 per ton by 2030, that means 1 ton of coal would cost $510 just in greenhouse gas pricing, let alone the price of the net coal, which is just above $100 a ton. So that's a huge incentive. That coupled with green procurement, the need for green steel, and an overall desire to increase one's ESG are all market drivers behind why the steel industry is so interested in this. And to give a concept, the Ontario steel industry alone, so there's 3 main mills in Ontario, they process or consume 1.7 million tons of coal every year to run their processes. And it's not that they're doing it because it's the cheap option. As I was saying earlier, part of it is required for the chemical reactions that are designed into these plants. So they can't easily switch to, say, natural gas for heat, which is lower carbon, because they need that ingredient in there. And of course, here's a nice picture of a self-unloader at ArcelorMittal Dofasco, and you can see this front-end loader driving up the top side of it to give a sense that it's a lot of material.
Andrew, sorry,
yes.
If you can go back to that, where you say your 1 ton of biocoal produces 0 tons of GHG, is it that it produces 0 tons of sort of new GHG, or is it just it doesn't produce any, or it just doesn't count because it was my poop a couple weeks ago and now it's going into that cycle?
That's exactly it. And that's why we use the term GHG, because this is certainly an accounting practice, but because we're part of this terrestrial carbon cycle, plants take CO2 out of the atmosphere, you eat it for dinner, it goes in the toilet, it makes biocarbon that produces CO2, it's cyclical. So it doesn't count from a net increase to greenhouse gas because it's neutral. So that's where the neutrality, the carbon neutral comes in, is that it's just cycling it through. So it's not net adding CO2 to the atmosphere.
All right. Thank you.
For sure. And so the 1,000-ton order, we announced that in March, and we're in the midst of fulfilling that for our industrial client, and obviously looking forward to continued orders and larger growth opportunities with them.
And that deal is being produced out of your London facility?
Correct.
And about how long, what is your production capacity? How long does it take you to produce that 1,000 tons?
Yeah, it's about a 9-month process. So our London plant is a little bit limited in scale, and certainly that's why we're actively pursuing projects where we can significantly increase that output with a couple of new projects.
Yeah. And when you price that, is it crudely the price of, you price it in the market where it's the price of coal plus the carbon credit value, and that's essentially kind of how you price it, or?
It's essentially, yes. And I would say, significant advantage that we have is that when we look at the competitive landscape in biocoal, our competitors are only able to produce biocoal. Our plants will be producing biocoal and renewable natural gas. And from a project plant economics perspective, the RNG revenue is going to represent 80% of the project revenue. So we can be much more competitive on our biocoal pricing because the project economics aren't tied just to it. But yeah, crudely, it's exactly that. It's what's the price of coal plus the GHG emission cost. That's what our biocoal goes for. And of course, there's additional value to the steel mills in that they have lower carbon steel and they can get into some of these green procurement opportunities into the future. But they're still a commodity business, and they need to worry about their bottom line.
I was just reading an article today that the big, I think mostly European auto manufacturers are looking to get sort of greener steel, and as not just going only batteries and so forth, but have all parts of their supply chain a little greener. And then this would, I presumably, count towards their greening of the steel.
100%, exactly. So that's on the biocoal side. So, we've got all of our plants, we always produce the two products, the gas and the carbon. So on the gas side, the first one I want to talk about is renewable green hydrogen. And of course, this graphic at the bottom is from the Ontario Hydrogen Strategy, and you can see they've got the green, the gray, the blue. They don't yet have the turquoise down here or all the other hydrogen colors that there are, but kind of green, blue, gray are the main ones. And what I'm showing here is that biomass into green hydrogen is already established. Like, regulators understand it, the market understands it. So we don't have to go out and educate the difference between electrolysis green hydrogen and biomass green hydrogen. It's fairly well established.
Does anybody care? Do they just care it's green hydrogen, or do they care if it's through electrolysis from a solar facility or from the waste cycle? Or
yeah, they just care that it's green. Okay. And because regulators and the like recognize it as green, our advantage here is that, running water through an electrolyzer uses a lot of electricity. And because of that, the electrolysis green hydrogen kind of lobby is pushing for higher prices for green hydrogen to make it viable, and makes total sense. Our production costs are certainly a lot less than that of electrolysis, but because we're green, we can capture the same value for our hydrogen, which I think is a pretty lucrative opportunity as well. And on the green hydrogen side, we obviously made this announcement since we last spoke as well, Martin, and that's with Hitachi, Zosen, and Inova. So this is their existing facility in San Luis Obispo. So what you see on kind of the left-hand side here is that's their biogas plant. So that's where they're making biogas. And then this big building in behind, that's where they store the digestate, the compost that they produce. And so we'll be taking that compost, it's about 18,000 tons a year, processing it and producing about 1.3 million kilograms per year of green hydrogen, go ahead.
What do they currently do with that digestate? Because if it still has PFAS in there, is it considered sort of a toxic-ish kind of thing? You can't throw it on farmland. What do they do with it?
Yeah, and that's the distinction, at least right now, between digestate and biosolids, is that digestate has much lower contamination. So generally speaking, it's used as a soil amendment practically, and this isn't specific to Hitachi, but to the biogas industry, is that the usual method is the biogas facility will pay for trucking and farmers will let you spread it on their fields for free. So there's a slight negative value to it in the disposal, but there's also the challenge that farmers don't want digestate in the middle of summer or the middle of winter, and these biogas plants operate 24/7, 365. So there is still a digestate management challenge that a technology like ours really helps to mitigate.
And so with this deal with Hitachi, is you're taking an existing anaerobic digester and you're tacking on your system to the end of it, adding another value-added cycle to it, sort of increasing the value of their output product. You're finding new value for it, and it sort of adds to the whole project.
Exactly.
And so these systems could, if the economics allow, could be attached to any anaerobic digester system kind of in the world, and presumably add value to it.
Absolutely, exactly, and specific to Hitachi, who've been great partners to us through this process. They just built their 100th facility globally, and they're very actively pursuing projects in the United States where we can help create additional competitive advantage for them, and they can provide a sales channel to get more of our pyrolysis units deployed in a more rapid fashion.
And does Hitachi kind of use the utility, they build, own, and operate it, or are they just a contractor who builds it for XYZ company and they sort of walk away from it?
Yeah, it's a bit of a blend. So San Luis Obispo, they, if you read their press release on it, they refer to that facility as their lighthouse facility. I would more call it a showcase, but it's one that they own, operate themselves. Other facilities, they take sort of any number of approaches, whether it's they're the the EPCM and they build the plant for a client and design it and do all the rest, or they take an operating contract, or they take a bit of an equity stake. I think it depends project by project, how they're involved and how they roll out that system. But they kind of do a pretty broad range of options.
Gotcha. And when you guys announced this deal, it was announced as a test project, I believe that. And so it sounds like they're testing you guys out a bit. You have to build the project. You're going to run it for them, and they're going to see if it actually works. So they get to test it out without, if something goes haywire, that's kind of, you've got it, that's your problem. You've got to deal with it. But if it does work, they've got a buyout option at the end saying, hey, it works as promised. We want this to be part of our solution. Is that roughly it?
That's roughly it. But I want to add that while we're testing it, all the revenue off of things like green hydrogen is ours as well. So there is a pretty significant upside for us on the during the time period where we own and operate this equipment.
Do you, with your deal with them, if you're allowed to say this, do you have to pay for their digestate, or is that you kind of get the farmer's rate where you shovel it into your tank and you get to use it?
Yeah, that's exactly it.
Okay. All right. And then presumably as it's structured, while you're operating it, you make it's your capital costs going in. You make the profits from selling the hydrogen and the biochar, and when they feel it's de-risked or whatever other corporate reasons they have, then they can pull the trigger on the option agreement, and then they'd write you a check for it. You'd stop getting the residual, the income generated off it, but you'd get a relatively big check paying for the cost and some of the future value of the project.
Yeah. So at that point is an equipment sale with standard equipment margin, and then we also do get an ongoing license revenue stream. Yeah. That's based on the value and the sale of the hydrogen off the project.
Okay, so you're getting and it's not a service contract; it's sort of a licensing fee or technology license fee trailer going off of it.
Yeah, it's a technology license fee that's ascribed to a percentage of the hydrogen revenue. We will continue to do remote monitoring and kind of remote service support, but the plant is then theirs to operate and maintain with our ongoing support. And obviously we've got a decent vested interest in ensuring that plant has maximum uptime, because we don't have a fixed service contract. We get a percentage of sale.
Okay.
On a license basis.
Gotcha. And for the green hydrogen, is there a spot market? Do you sell it, or do you need to still find sort of a long-term takeoff agreement for what you're going to produce? How is that market for the green hydrogen?
Yeah, it's a little different than, say, the RNG, in that it is, even in California, it's still evolving. So there are green hydrogen markets in California. But what we are doing is I wouldn't say long-term, more of a 3-year offtake agreement, because the market's much more difficult to predict where it's going to be and what the pricing is going to be in 3 years. And, I certainly have a strong belief that hydrogen prices, green hydrogen prices, are not going to go down in 3 years. So, we're obviously hesitant to try and lock in for any longer than 3 years and see the green hydrogen price double or triple 3 years from now as demand continues to grow and the need for decarbonization in California, in particular in this case, continues to grow.
Yeah. Okay. All right. And the cost, like the sale of one of these systems, I'm not sure how much you can say, but it's around a 5 million-ish kind of equipment sale. Would that be kind of in the right kind of ballpark?
Yeah, ballpark order of magnitude. That's it. Yeah. Okay. For something of this scale, sort of a larger plant doing, say, RNG, would be more on the $12 to $15 million. So that's kind of the range of plants depending on size and output.
Okay. And sorry, and an RNG plant would be that's running off of the waste. That's more expensive, or did I miss something?
Yeah, so I kind of threw two things into that higher number. One is it's a bigger plant, so it's more expensive, and then as I was trying to explain earlier, we go syngas that produces green hydrogen that then can produce renewable natural gas. So if we cut off the renewable natural gas component, it's a lower cost project because we've got one less process step.
Gotcha.
Yeah. But that kind of gives you the range of where capital will range. It'll be from that 5 to that 15 really in that window.
And are these Canadian or US dollars?
Those are Canadian dollars. So
yeah. And then this I believe you're expecting to commission it and be up and operating in the spring of next year?
Yeah, so equipment will be able to be delivered in the spring. If everything goes extremely smoothly with the permitting process, it's a reasonable time frame to expect commissioning in the spring. We may end up dragging that out to kind of late summer if there's any sort of delays in permitting. That, no matter what jurisdiction or where the project is, permitting is always kind of the longest lead item, and you can't get started on it until the definitive agreement's in place. So as soon as we signed the deal, we went down to St. Louis Obispo and met with all the permitting folks and started that process. So we're cautiously optimistic that late spring is still possible, but that's kind of the range that we have to give for now while permitting goes through its channels.
At what point do you pull the trigger on your contract manufacturer to say, okay, start building it now, we're confident enough in the permit? Do you wait for the permit to be issued, or a few steps earlier can you do that?
No, we're definitely going a few steps earlier. It's not, at this point, it's not an issue of are we allowed to or not allowed to. It's how long will the review process take? And, it's kind of minor things. Will we need to put in an additional scrubber on the exhaust gas to control NOx in the California market? I mean, we've done the air modeling and we've put in sort of that air pollution requirement, but they may ask for a little bit more, or there's sort of, it's that level of detail. So it's not a binary yes or no. It's we're very confident it's yes. It's just, do we have to add a little auxiliary piece here or there to meet any regulatory requests?
Yeah, we've got a question here. How long is the trial period with HZI? I guess, when could they pull it? When's the earliest they could pull the trigger, or how, that window? How?
Yeah, so the earliest they could pull the transfer option trigger is 12 months from when it's reached stable operation. So we wrote that in there to kind of make sure we had the opportunity to drive at least 12 months of revenue from the project.
Yeah.
And then they're of course under no obligation to issue the transfer. And, if we keep operating, we keep getting those revenues. There's no cap on when they can initiate the transfer. They have to give us, a 6-month notice period. So they can't just, kind of snap the fingers. There's a transition period built in, but we get to operate it and we get to see the revenue off of it for at least 12 months.
Yeah. And do you have to pay them rent or sign a lease for the chunk of land you're sort of using of them right next to it, or
there's a lease agreement only in the sense of it's our plant, so we need to have, obviously the right to operate it, contracted, insurance needs to be covered. Some of the insurance is ours, some of it is theirs because it's on their site. So that's all built into the lease agreement, but it's a nominal value lease agreement.
Gotcha. Just to set up the structure of it. Okay.
Correct.
All right. And then on the revenue side to be generated, how many tons of hydrogen's produced, multiplied by whatever price you want to throw at it, and then the biochar that's from it, the price of coal plus the GHG credits. that'd be kind of the revenues looking at it.
Exactly. Yeah. Yeah.
All right.
And so the other gas option, of course, is the RNG, and this is where, like I was saying earlier, we're looking to actively pursue projects. I think the interesting one is, and this is a similar slide to the last time we spoke, is that Anergy commissioned a study, and they said, you know, for us to reach 10% of our grid being renewable by 2030, where does the gas come from? And the study showed that over 80% would have to come from second generation technologies, which is what pyrolysis is, because anaerobic digestion cannot convert woody materials into RNG. That's why we have this opportunity with biogas plants to process the digestate. It's all the fiber that these bacteria can't consume, these microbes can't consume, they can't do anything with it. And there's just not enough food waste in Quebec to meet that 10% target. So it's not saying biogas is bad or wrong or, you know, we're better there. It's just that the feedstock's not there. Whereas, you know, certainly in Quebec and Northern Ontario and in British Columbia, for that matter, there is a significant amount of biomass. And for us, we're not looking at, say, competing with the sawmills. We're actually helping support that forestry industry because we're taking residuals like sawdust, like bark, like hog fuel from these facilities. And that's what we're converting into both RNG and biocarbon. So this is the market that we're certainly actively pursuing project development opportunities in.
Yeah. And given that they have these targets, some of them are mandated, some of them are sort of aspirations by the corporations or the jurisdictions, that could that trigger them, okay, we want to hit 5% by whatever year, so we're willing to pay a little bit more in offtake agreements just to sort of encourage people to produce more of it?
That's exactly it. And you see that certainly Fortis is more public about it. So, you know, they've got a mandate that at the last time I checked in on it, they could pay up to $30 per gigajoule of RNG, and kind of your household price is, you know, $3 to $5 a gigajoule. So there's certainly a premium put on it. And as they come under increasing pressure to meet those targets, and as they're not kind of getting close, I think it's fair to assume that those contract prices may continue to increase.
Okay. Thank you.
And then, you know, we talked a little bit about the biosolids destruction, and you know, as I was saying earlier, that's where we call it a secondary market, in that we think it's a near-term opportunity to sell the equipment. But again, as I mentioned earlier, we're not actively pursuing kind of building our own plants or having a really long-term operating BOO aspiration in the space. But I want to add a little bit more around this landfill cost increase. And it's due to this contamination of PFAS. This is that forever chemical polyfluorinated alkyl substance. But, you know, the way to remember it is it's in Teflon, Gore-Tex. If you have a product that is non-stick or water resistant, it has PFAS in it. And since it's in so many products, it gets into the wastewater and it gets into the landfills. And that significantly increased piece. When we started looking at the space about 4 years ago, the tip fees, so the cost to dispose of biosolids in landfills were about $20 a ton. Kind of 2-ish years ago, it was $40 a ton. Now we're looking at a project in the northeast of the United States where the alternative, the tip fee, is over $80 a ton. So that's a pretty significant increase in tip fee over such a short period. And, you know, in that space, about 6 months ago now, I guess, we co-presented with Jacobs, one of the world's largest wastewater engineering firms, where we presented our combined research showing that our high temperature pyrolysis does in fact destroy the PFAS, allowing for more traditional biosolids management processes to then come back to the forefront. And that was originally biosolids were spread on fields because there is nutrients in them. So by destroying the PFAS, we're allowing the carbon and those nutrients to be able to be land applied again in those markets and really offsetting that massive tip fee requirement.
All right.
And so when we talk about scale up in projects and BOO, this is, you know, kind of that clean fire, renewable natural gas. And this is a single module of our largest facility. And so you can see all the components are kind of on stands. Each one of those main components you can see is designed and sized that it could be put in a shipping container and brought to site. And what we are actively pursuing is to construct a facility that eventually will be producing 1 million gigajoules per year of RNG and about 25,000 tons per year of clean fire. And that's in a phased approach. So one module, the module we're looking at right now, produces about 250,000 gigajoules. So 1 million gigajoules would be 4 of these modules processing and producing both the RNG and the clean fire.
So your system is a module. You're not going to build 1 million gigajoule facility. You'd buy 4 modular units and scale up in that way.
Correct. And that there's a couple of keys about why that makes sense. One is for pyrolysis, because it's heat transfer. You can't make the heat tubes infinitely bigger in diameter and build a bigger plant, because then you have trouble getting heat to go through the tube, through all the material into the center. Like you just have, that's a, you know, thermodynamic limitation. So your only option is to make it longer. And so that presents other constraint concerns. So instead of making a giant long kiln that has a lot of issues associated with it, and that's what they do in the cement industry. They have these huge long kilns for those same reasons. Our approach is we build the kiln that can fit into a shipping container so that we can take advantage of factory assembly and then put modules. The other benefit is that we can put in a 2-module system producing 500,000 gigajoules per year of RNG for about $25 million. Get that plant pipeline connected, get that plant generating revenue and cash flowing, and then it's a lot easier to go and you know, find a number of different financing options to expand the plant instead of having to build one giant $100 million facility and get all the financing lined up and all the risks that are associated with that. We'd rather build 500,000 gigajoules a year for 25 million, get that running, and then expand it out from there. To me, that makes a lot more sense and is something that is much more rapidly deployable. You know, we could do this in 24 months instead of 5 years, like a sort of mega project would be.
Yeah, and I would guess, especially when you're starting out and there's still a learning curve and a credibility curve you're working up after your 20th project, maybe you can go straight to the $100 million thing and go from there. But sort of your baby steps, this is a good way to start off.
That's right.
Just another question from the audience. You're referring to the HZI deal, or I guess it would apply to anyone, asking what would the estimated payback period on one of these units be? So if you're spending 12, 15 million bucks on one of them, what are, obviously the output revenue is changing, but can you give us a bit of a rule of thumb on what kind of payback period we're looking at?
For sure. And maybe because I've been doing all the talking, I'll let Mark jump in and
I'll add my 2 cents. Andrew's been doing such a great job. Basically 1.5 to 3 years, depending on the assumptions. That's the range.
Okay, that's and this assumptions are basically the input costs and the output value.
That's right. That payback range 1.5 to 3 years doesn't include any subsidies, government funding, tax credits, nothing. That's just the raw economics based on the inputs and the outputs.
Yeah, and in terms of operating costs, you don't use much energy because you're creating your own energy to do that, and then you've got 1 or 2 people kind of operating the facility, and
exactly. Yeah.
And for anyone who wants to do some back of the envelope math, one module consumes about 250 kilowatts of electricity to run motors, blowers, compressors, etc. But we don't need any ongoing, natural gas or propane or the like. That's just to fire the system up. Once it's at temperature, it's producing its own gas and running off of that. So it does become pretty low value. Number of people, it's always at least 2 on site for kind of health and safety reasons more than anything, because it is a quite an automated process. But kind of 2 per shift, and a site planner and a little bit of a maintenance staff, but it's still a pretty light headcount facility.
So really the main driver is if your input costs, if there are any input costs, or it's sort of free because you're taking off someone's hand, or maybe you can even charge a tipping fee for it. And then it's just straight a few operating costs, but primarily what you can sell it for. That's the value driver. All right. Okay.
Yeah, that's it. So kind of we've covered all of this, kind of what are we doing and what are we up to. So this is kind of the end of markets and technology. Now I'm happy to always talk about the rest of the business. So, I mentioned earlier, we do have an environmental consulting group. They do get about 70%, 75% of business from repeat customers in environmental compliance, property due diligence, permitting, and carbon finance. But you may kind of clue in that environmental compliance, property due diligence, permitting, and carbon finance are all things that Char needs as we develop our own build, own, operate projects. So it's a unit that is generating revenue for the company now, and kind of in-houses a lot of that upfront development work, such that we can kind of reduce our outlay and our burdens to do project development at the front end by having all of this expertise in-house.
All right.
We talked about this. I mentioned the 8 capital report as well. And so a little bit on management and board, but I know we're getting tight on time. So Martin, I don't know if you want to stop it there and open the floor for any additional questions.
Yeah. So if there are any questions out there, and I think there is one. No, I think we dealt with the payback period. To switch a little bit, you read one of your newer news releases. You talked about the technology with Anergy. Sorry, I think I'm saying it wrong. Could you just talk about that one, that deal? What does that mean for you and for shareholders?
For sure, yeah. So Anergy is the pronunciation for you, and basically, sort of as we've described, our IP has always been around process. So kind of the recipe book. That's what Char was founded on. Is how are we making these outputs? And how are we making them in a way that the market really wants them? Like why are we able to get traction with the big steel mills? Because we're developing products that meet their needs. So that's always been our core IP. When we built and commissioned our first plant, we collaborated with Anergy on that system. So we worked with them to custom design it for our needs. Anergy had been building kilns in the mining space, so processing sort of minerals and the like for years, and it started to go down this path as well. So we linked up with them, and we've always been kind of offering the entire package, which included, we'll say our recipe book and their oven, and obviously the collaboration that's included. But with the license agreement and the partnership agreement in place, we're now taking the lead on the overall equipment design, process, and manufacture. So we're doing, the detailed engineering, the procurement, the assembly, subcontracting parts of those out as need be. But basically what that allows us to do is be even more cost competitive in our technology offering. We're able to own more of that process, which when we're looking at biosolids projects, say we're bidding in that space, we can come in at a more competitive price and still have, a very healthy margin. And on projects we're building ourselves, we can in-house a lot more of those costs and end up bringing it to completion for an overall lower capex than we would have under the original or previous arrangements.
All right. Okay.
So it's all about exclusivity and kind of cost savings, which allow us to generate better margin on the project.
All right. You've had a busy year. What should investors be looking for over the next, I don't know, through the end of the year, for the next 6-9 months, whatever you want to call it? Is it just all about the HZI project, getting that accomplished, or you talked about $100 million sort of pipeline of business? What kind of cadence to new business or new projects or should we be expecting?
Yeah, no, it's a great question, and for those who kind of go back and look at our original interview, you would have heard me talk about the first thing we were going to talk about in 2021 was a clean fire order, followed by a digestate to green hydrogen, followed by a renewable natural gas project, and so we're still on track for that sort of process of announcements. We've kind of announced 2 of the 3 as we kind of said we would, and I think we're still very much on track to make that RNG project before the end of this calendar year. And of course, there's other projects within that pipeline that as they come, we would expect to press release. So we're certainly seeing the cadence of our news and of meaningful news increasing through the fall and as we go forward.
And on the RNG project, would that be sort of more of an equipment sale type project, presumably, or a more like utility type build, own, operate kind of structure?
Yeah, it's on the build, own, operate side of the spectrum.
Yeah. You raised a bunch of money earlier in the year. You've got to spend some money to build this facility down in California. How good, and you are generating some business from your existing stuff, and you've got a few orders. How is your cash situation? What can you get accomplished with your balance sheet at this point?
Yeah, Martin, we've got over $3 million left from the raise. That's adequate to meet all of our existing obligations, including the California plant. So we would only go to market if some of these other larger orders came to fruition within the time frame that Andrew mentioned. Other than that, we're adequate. We've got no debt.
Are you at all planning on like in future projects, like project optimization, you'd associate debt with the project and so forth, but with this first one, are you going to be using any debt to fund the building of the HZI project?
Yeah, we would like to. Realistically, that might slow us down putting debt on that project because we are proving out the technology in that commercial setting. So the debt funders that we've spoken to would like to see our system up and running for at least 30 to 60 days on a continual basis.
Okay. All right. If there are, we've had a couple questions here. If there are any final questions from the audience, please throw them up quickly as we need to be wrapping this up here. Andrew and Mark, are there any points we haven't hit upon or that we should dig into more? Or I think we hit the big HZI project. I think we dug into that well. And then the Anergy one as well. Anything, maybe talk just briefly that RNG grant, or I don't know, I forget what from that recent news release. Can you just talk about that briefly?
Yeah, so that was from the Natural Gas Innovation Fund. So that's a fund supported by a number of the Canadian gas utilities, and they put money into technology demonstration. So that's adding renewable natural gas capabilities to our existing London plant to allow the utilities to see how it operates in a more rapid deployment. So we expect that to be commissioning in March, this coming March.
All
And
right.
of course, the gas utilities are certainly the ones we want to be involved in that project so they can see it, evaluate it, and get even more comfort with it. Which goes to your previous question, Martin, about debt. Is with that project running, there's a lot more comfort around adding some component of debt to specific projects going forward.
Yeah, yeah. And I would think the debt would, whatever, all things being equal, the further out the technology gets proven, the cheaper and easier things are going to be.
Absolutely.
Yeah. All right. Well, I'm not seeing any more questions here when we're tipping over a little bit over an hour here. So thank you very much for joining us, and any final sort of closing comments?
I mean, from us only that, I think we're just starting to see that momentum build. I know for Mark and I, things are starting to get really exciting around here, and we're pretty eager for the next year to roll out and to let us deploy some of these projects and kind of really see how this company and this technology perform. So we're pretty excited.
All right. All right. Thank you very much, guys. That was very good and thorough. Have a great day, and maybe we'll talk to you again after a few more projects get announced.
Sounds good. Thanks, Martin. Appreciate it.
Martin.
Thanks a lot.